real-time systems often rely on distributed software systems. So it's crucial to establish interoperable interconnectivity between these systems so they can communicate with each other. Now it's getting more common for system designs to be built on event-driven architecture. Why? Because this way you can enable efficient real-time communication between system components and systems without them being aware of one another. In this video, I'm going to talk about event-driven architecture and its most commonly used messaging pattern, publish-subscribe. That's because the data distribution service is implementation of event-driven architecture. I will explain how things work within event-driven architecture, what differentiates this architecture from other architectures, and if this architecture is good fit for your system. Event-driven architecture has suddenly become a hot topic between system architects. Maybe it's because Apache Kafka has emerged. But event-driven architecture is a rather old concept. It was when message-oriented middleware and publish-subscribe communication model has emerged. And it was in 1990s. So it is more than 30 years, but still nowadays synchronous communication continued to be used. It was with service-oriented architecture where web services were used. Nowadays it is microservices where APIs, application programming interface is used. But it's still synchronous communication. Synchronous communication works as follows. Client makes a call and wait for the server to respond with requested content. But event-driven architecture is a shift from tightly coupled synchronous communication type where request-response communication model is used to loosely coupled asynchronous communication type where point-to-point and publish-subscribe communication model is used. What is the differences between event-driven system and request or command-driven system? In a request-driven system, you ask questions from others. In command-driven system, you tell others what to do. In both cases, you then wait for the response. But this leads to tightly coupled systems. And when it's a large system, it can cause problems with availability, because the failure of one part of the system can cause problems and failure of the whole system. Also, in such tightly coupled systems, there is a problematic to make a change, because when you make a change in one part of the system, you probably need to make a change in different part of the system, because they are tightly coupled. An example of a communication in a request-driven system could be, you discovery server, give me all services that I can communicate with. The data in such system are treated as data at rest because the data are stored somewhere and I can retrieve them. An example of command-driven communication could be, you brake control system, I command, stop the car. But in event-driven system, you tell others what you did and you ask for state changes. And the difference is that others determine what they do. Not you, but they. And you don't need to wait for the response. An example could be, I want the state of the car to be stopped. And I don't need to know who accomplished it. It just happened because some service probably brake control system, accomplish it. But I don't need to care about who accomplished it. In the data in such system can be treated as data in motion, because everything is moving. I sending what I did, and I send and ask for the state changes, and everything is moving. Imagine, for example, a patient in hospital who is monitored by a medical device. If a certain threshold is exceeded of the monitoring variable, I need to react immediately. In that case, probably I would automatically apply some medicine and I inform the medical staff. But when I use a request-driven system to ask if something happened, then it will be very inefficient, because 99% of the time nothing may happen. And when it's happened, I want to know immediately, so I can react immediately, not in the 5 seconds, because I would need to ask, has something happened? No. Has something happened? No. So in these cases, the event-driven architecture is better choice. What are the basic building blocks of event-driven architecture? Event-driven architecture consists of event producers and event consumers. Event producers, like sensors and applications, generate a stream of events. And event consumers listen for these events and process them and react to these events. For communication between event producers and event consumers, there is used event channel. This channel can use point-to-point communication model, where queues are used, so only one from many consumers consumes each message. For this kind of channel, you can use ActiveMQ or RabbitMQ, for example. Or this event channel can use publish-subscribe communication model, where topics are used. So every subscribed application obtains the message and can process it differently. For this kind of event channel, you can use MQTT or DDS, for example. Or this event channel can use event streams, where events are written to a lock. Application can connect to this stream and read parts of this stream. This is allowed, for example, by Apache Kafka or NATS streaming. There are several benefits of using event-driven architecture, especially when using publish-subscribe communication model. These are scalability, loose coupling, fault tolerance, and asynchronous communication. Let's go through them one by one. Scalability. Event-driven architecture allows for great horizontal scalability, because one event may trigger responses from multiple applications with different needs and provide different results. Loose coupling. Producers and consumers are not aware of each other. There is either intermediary that receives events from producers and send these events to interested consumers, or there is a discovery phase where producers and consumers discover each other, and after that they can communicate peer-to-peer. And this allows for loose coupling of applications, and this facilitates their modifying, testing and deployment. And unlike point-to-point application integration, the application can be easily added to or removed from a system. And this allows the system to evolve. And this is very important for IoT systems, especially for IoT systems. Then fault tolerance. Loose coupling goes hand in hand with fault tolerance, because the failure of one application has no effect on other applications, so the system as a whole can work at least partially. So this leads to a greater and better resilience of a system. And asynchronous communication. Events are sent asynchronously. That means that events are sent as they happened by producers, and consumers consumes them right away or after some time if the consumers are not available, but that does not affect or block producers. That's important. So this leads to better responsiveness and performance of a system. That's all. What are the disadvantages of event-driven architecture? There are several considerations you should take into account when you are dealing with event-driven architecture. It's because of its distributed and asynchronous nature. In general, it's more complicated. There is increased complexity because you have a lot of parts in such system. So you've got less control over the processing flows, and it's more difficult to test and debug everything. So it's crucial you invest in observability infrastructure, so you got monitoring, logging and tracing in place. Then you've got only an eventual consistency when you're dealing with data and state changes in your system, because it takes some time to propagate the data or state changes within your whole system. Then it's more difficult to implement transactions when the transaction spans a lot of applications or more applications, several applications in your system. Then there is a possibility for duplicate processing and out of order processing, because the network is unreliable and you may run several instances of your consumers to get some scalability and resiliency in your system. So these were the challenges you will face when you are dealing with system that complies with event-driven architecture. When to use event-driven architecture? You should consider using of event-driven architecture in the following use cases. Your system consists of multiple subsystems that need to operate in response to the same event. Or you need to continuously monitor the state of the resource and receive notifications when the state changes or updates. So that means you need a very responsive system. Or you need a complex event processing, such as pattern matching or aggregation over time window. Or you deal with high volume and high velocity data, such as IoT data. Or you simply want to improve your existing system and make it more scalable and responsive. These were the use cases where you should consider the usage of event-driven architecture. What are the technologies you can use to build event-driven architecture? There are a lot of technologies and tools you can choose from. you can choose from communication protocols like MQTT or AMQP. You can choose from middlewares when you are building a solution on premise. So for example, you can choose ActiveMQ, RabbitMQ, Apache Kafka, DDS, NATS, Zeno. Or when you are building a cloud solution, you can choose from different providers. You can choose Amazon, you can choose Microsoft, and you can choose Google. All of them support like message queues, publish, subscribe, communication, or even streaming. So for message queues, you can choose simple queuing service from Amazon. You can choose Service Bus from Azure. You can choose Google Task, Cloud Task from Google. Or when you are needing publish, subscribe, communication, you can choose simple notification service from Amazon, Service Bus that supports topics from Azure, and Google Publish Subscribe service from Google Cloud. And when you need event streaming, you can choose Amazon Kinesis. You can choose Event Hubs from Azure, from Microsoft, and PubSub services from Google, as well as data flow service for analytics. So there is a lot of technologies you can choose from to build event-driven architecture. Event-driven architecture or not event-driven architecture? That's the question. Event-driven architecture is not a universal solution. It's not a silver bullet for all use cases, for all scenarios without exception, for all your problems. If your system is simple and unlikely to scale up, or you don't need a real-time responsive system, it's not necessary to overcomplicating things. In that cases, request response model will suffice for your system. And this model is still relevant for variety of use cases. In any case, first of all, it's necessary to decide what architecture you need for your system. And only after that, choose the appropriate technology, not the other way around. Because technology can simplify design and implementation and maintenance of your system. But when you choose the wrong architecture, you will probably need to start over. So I hope that I helped you comprehend what the event-driven architecture is, and now you can better decide if you need it or not.